Hi, my name is Sora, and I'm from Miss Tang's class, and I'm talking about groundwater and filtration system. Let's start off with a little video of explaining what groundwater is.
Hello. Did you know that groundwater was used by early Americans for over a century? In fact, groundwater was used more and more as California expanded. Fact: groundwater and surface water are not two separate water sources. Not only did settlers rely on our groundwater, but so does an entire economy. With technology today, we've helped this natural water system to become more effective. However, this system can be easily damaged. Fact: our water supply is sensitive. If toxins are taken in, we feel it immediately. It's our duty as members of society to protect the groundwater supply. We can do this by following the guidelines stated in all public facilities and putting out our extra effort to manage our waste consciously. Let's all pitch in. Every little bit helps.
What is groundwater? Groundwater is water that comes from the ground. Groundwater is stored in the ground in materials like gravel or sand. It's kind of like Earth is a big sponge holding all the water. Water can also move through rock formed like sandstones or through cracks in rocks. Due to its protected location underground, most groundwater is naturally clean and free from pollution. Where does groundwater come from? Groundwater comes from rain, snow, sleet, and hail that soak into the ground. The water down into the ground because of gravity, passing through between particles of soil, sand, gravel, or rock until it reaches a depth where ground is filled or saturated with water. The area that is filled with water is called the saturated zone, and the top of the zone is called the water table. The water table may be very near the ground surface, or it may be hundreds of feet below. At this point, the water moves towards sites of groundwater discharge, such as local springs, lakes, and oceans. There is a great deal of groundwater available to us. In fact, 98% of the world's total supply of drinkable water is groundwater. The water in lakes, rivers, or ocean is called the surface water because it's on the surface. Groundwater and surface water sometimes trade places. Groundwater can move through the ground and into the lake or stream. Water in a lake can soak down into the ground and become groundwater. An area that holds a lot of water, which can be pumped up with a well, is called an aquifer. Wells pump groundwater from the aquifer, and then pipes deliver the water to cities, houses in the country, or to crops. Most groundwater is clean, but groundwater can become polluted or contaminated. It can become polluted from leaky underground tanks that store gasoline, leaky landfills, or when people apply too much fertilizer or pesticides on their fields or lawns. When pollutants leak, spill, or are carelessly dumped on the ground, they can move through the soil. Because it is deep in the ground, groundwater pollution is generally difficult and expensive to clean up. Sometimes people have to find new places to dig a well because their own became contaminated. How is groundwater contaminated? Basic tests can determine if bacteria and nitrates are present. More sophisticated and expensive tests are required to detect pesticides and chemicals. Local health agencies and extension educators can assist in obtaining well water analysis. In the past, because we did not understand how vulnerable groundwater was, we have been careless. Even today, gasoline and other harmful liquids leak from underground storage tanks into the groundwater supply. Pollutants soak into groundwater from poorly constructed landfills or septic systems. Groundwater is polluted by runoff from fertilized fields, livestock areas, abandoned mines, salted roads, and industrial areas. Few people realize it, but the homeowners can contribute to groundwater contamination by dumping household chemicals down the drain or pouring them on the ground. Groundwater is also one of our most important sources of irrigation water. Unfortunately, groundwater is susceptible to pollutants. Groundwater is generally a safe source of drinking water. However, there are concerns that contamination may increase as toxins dumped on the ground in the past make their way into groundwater supplies. Pollutants that contaminate groundwater may be some of the same pollutants that contaminate surface water. Compounds from the surface can move through the soil and end up in the groundwater. In addition, it is possible for untreated waste from septic tanks and toxic chemicals from the underground storage tanks to contaminate groundwater. The hydrologic cycle. From the time the earth was formed, water has been endlessly circulating. This circulation is known as the hydrologic cycle, otherwise known as the water cycle. Groundwater is part of this continuous cycle as water evaporates, forms clouds, and returns to earth as precipitation. Surface water is evaporated from the earth by the energy of the sun. The water vapor forms clouds in the sky. Depending on the temperature and weather conditions, the water vapor condenses and falls to the earth as different types of precipitation. Some precipitation runs from high areas to lower areas on the earth's surface. This is known as surface runoff. Other precipitation seeps into the ground and is stored as groundwater. Groundwater begins as precipitation and soaks into the ground where it is stored in underground geological water systems called aquifers. Sometimes groundwater feeds springs, lakes, and other surface waters, or is drawn up from the ground by humans through wells. The groundwater then can evaporate, form clouds, and return to the earth to begin the cycle over again. What is in our groundwater? There are 5 elements that is in our groundwater: arsenic, copper, lead, manganese, strontium. They are all dissolved in small amounts, but that doesn't affect our health in any way. In Toronto, the water has chlorine and fluoride in it. In Toronto's water, chlorine is used to control bacteria, algae, and viruses that can be found in the water. It's considered one of the most important tools to disinfect drinking water. It's actually been used for more than 100 years and is responsible for ending disease epidemics that were widespread prior to its use. If extra chlorine is used to ensure disinfection of the plant before the water is pumped to your home, sulfur dioxide is added to reduce the chlorine to a residual level. Ammonia is then added to stabilize the residue. All of this meets Ontario's regulatory requirement for water. Fluoride is added to treated water to reduce the risk of dental cavities. Toronto Public Health advises the city about setting the fluoride target level for treated water, and in keeping with Health Canada guidelines, our fluoride level maximizes dental health benefits and minimizes concerns over overexposure. Chlorine and fluoride are key ingredients to water quality and public health and safety. There could be 3 main problems with tap water. 1 is chlorine, 2 is fluoride, and 3 is other contaminants such as PCBs, THMs, heavy metals, or bacteria. So we're going to look at the fluoride problem first. In 1973, British Columbia was considering mandatory fluoridation. They gave the job of researching and reporting the topic to Richard Folks, MD. Folks then wrote a 1,900-page report, and he recommended that the legislation be passed to make fluoride mandatory in Canada. Based on that work, Canada began to fluoridate. Little by little, Folks found out that the statistics that his researchers had based their findings on were largely falsified. It took Folks several years to uncover the truth, but by 1992 he shocked the country by backing down from his original recommendation. I now hold a different view. The fluoridation of community water supplies can no longer be held to be either safe or effective in the reduction of dental caries. Therefore, the practice should be abandoned, quoted by Folks, 1992. Folks is not some tree hugger from Santa Cruz. He is one of Canada's top scientific researchers. Many cities in Canada listen and stop fluoridating. Another pro-fluoride Canadian scientist, Dr. Hardy Lineback, changed his tune when he learned that 30 to 60% of Canadian children now have visible signs of overexposure to fluoride, something called dental fluorosis. Chlorine. The experimental use of chlorine began in the 1890s to combat waterborne diseases such as cholera and typhoid. It quickly gained wide acceptance because of low cost and high efficiency in killing just about everything hazardous in the water. Lead pipes and lead solder in the distribution systems are the main source of lead pollution. Houses older than 20 years and less than 5 years are most at risk. Also, houses in areas of soft, low mineral levels water tend to corrode the lead from the pipes more easily. The water filtration system. The water purification or bottling system preconditioned skid consists of 3 major components. Number 1, commercial-grade multimedia filter to remove particulate materials prior to other water treatment and bottling. It can be used by itself to process spring water prior to disinfection and bottling. 2, dual/twin alternating water softener, capable of providing 24/7 soft water operation for both distillation and reverse osmosis treatment systems. 3, carbon filter, to remove any traces of organic chemicals present in the incoming water, such as pesticides, chlorine or chlorine byproducts, and etc. These 3 units are integrally mounted on a stainless steel kit, pre-assembled and ready for an online installation. They can be integrated with either reverse osmosis or steam distillation water purification systems together with the necessary disinfection components. Now here is a video explaining water filtration.
H2O evolution uses 5 stages of processing to produce the finest quality of water available. First, the water passes through a sediment filter, designed to remove simple debris that is common in tap water. Next, the water passes through an activated carbon filter that has the capability to remove pesticides, herbicides, chlorine, ammonia, and other chemical compounds. The third stage is a commercial reverse osmosis membrane. Reverse osmosis is the most common method used to manufacture purified water. It has the capability to remove lead, nitrates, giardiasis, and most all other impurities. This reverse osmosis membrane will actually filter the water down to 0.0009 micron range. That's smaller than the range of an electron microscope. This provides assurance your water is indeed purified. The fourth stage passes your water through another activated carbon filter for a final polish and to ensure the removal of all taste and odors. Last, the fifth stage exposes your water to an ultraviolet lamp, which provides germicidal disinfection with no chemical residual. This UV lamp ensures there is no chance for any bacteria or virus to live in our storage tank, giving you the finest water quality available.
And thank you for listening to my presentation.